Welcome to Modern Web Dev with Blazor WebAssembly and ASP.NET Core. My name's Jason Taylor and I'm an SSW Solution Architect. You can find me online at jasontaylor.dev. Now, enough about me. We're here to talk about Blazor. It's kind of a rapid fire introduction, isn't it? But that's okay. Let's talk about Blazor. I'm happy to say that now is the perfect time to get started with Blazor. Blazor's been running production systems for over 2 years now. So it's battle tested. And what's more, next month, Microsoft is releasing .NET 6, the long-term support release version of their hugely successful development platform. So if you're like me, you've probably been running on preview versions for a while, and we're already up to RC2. And I've got to say, it's pretty stable. Everything is working how I like it to. So in this talk, I want to get you started on the right foot with Blazor. I'm going to demonstrate tools, components, data access, code generation, forms, validation, component libraries, and more. You ready to get started? Let's do it. So with SSW, we have a really cool SSW Rewards app, and I just wanted to give you a heads up on this. If you search SSW in the App Store, you can download it and install it. Now, at the end of this presentation, I'll share a QR code that you can scan, and you'll be able to earn some points and win some prizes. So what is Blazor, I hear you ask? That's a very good question. Now, I want to be clear. This is not an introductory talk, but there's something in it for everyone. I'm going to share some things that I think are really important when I'm building a Blazor application, but I'm also going to share you a lot of resources. So if you are getting started, I'll help you get off on the way. But let's start. Blazor is a free and open source web framework. It allows you to build interactive web apps using C#, HTML, and CSS. So you'll be using C# mostly instead of JavaScript. With Blazor, developers use the same language, frameworks, and tools on both the front end and the back end. And this will accelerate development, simplify maintenance, and reduce complexity. Let's take an example. If you already know C#, you already know date time handling. You already know validation, managing collections, and so on. You don't have to relearn that. You get to leverage that knowledge across the entire app. You're not going to need multiple skill sets and teams to build a modern web app. You'll be able to easily share code between the front end and the back end, since both are going to be written in C#. And as I mentioned, Blazor's production ready. It's time to go live. It's properly supported and officially released by Microsoft, and many companies, including SSW, already have Blazor in production. All right, just like that, it's time for the first demo. So this one doesn't really need an introduction, so I'll just dive right in. So let's see, I've got an empty directory here, but I'll go ahead and create a Blazor demo folder, and we'll jump into there. Now, let's start by checking what version of .NET Framework I'm running. So if I go .NET version, if I get bad command or file name, I don't have the .NET Core CLI installed. But I'm running version 6.0.100 RC2. So let's see if that's the latest version. If we want to do that, we can go straight to .NET. And in .NET, we can go to download, scrolling down a little bit, all .NET downloads. .NET 5 is the current version. And we can go to .NET 6. So we can see I'm on RC2, and the latest version is 21.505.57. Or is it 21.505.57? So I'm on the very latest version. But if you're not on the latest version, then you can go ahead and download it for your OS. You can grab the installer or otherwise. Pretty easy to get started. So once you've got that up and running, once you've installed the .NET 6 SDK, you can go .NET New, and you can have a look at the Blazor templates. So when we go list, we can specify the keyword Blazor just to filter the templates. So we've got 2 templates available. So the first one is the Blazor server app, and that's built for actually creating Blazor applications that run on an ASP.NET Core server and communicate with the client using a SignalR channel. Tonight, we're going to be focused on Blazor WebAssembly app, and that's when we're going to be running C# in the browser. So Blazor WebAssembly will run in the browser. So I'd like to explore some of the options that are available with that template. So if I go .NET, new Blazor WebAssembly, and we change that to help. It won't create a new project. It'll just give us the help that we're looking for. Now, there are a lot of options available in this template. but they're mostly related to authentication. So standard out-of-the-box authentication with identity and identity server, or identity and Azure AD B2C. Here we go. So the main ones are the target framework. So framework, the target framework for the project. Hosted, this is a good one. If specified, includes an ASP.NET Core host for Blazor WebAssembly. We'll be turning that on. Auth, so you can select one of the authentication methods. The default is none. Let's see, scrolling down. We've got PWA, so if specified, produces a progressive web application supporting installation offline use. So that's definitely going to help you get up and running. And finally, if you do select an authentication method other than none, you might want this option, use local DB. When you're running this from the command line, by default, it's going to use SQLite. If you include this option, it'll use local DB. Might be preferable depending on your environment that you're programming in. All right, let's go ahead and create a new Blazor WebAssembly app. So we go .NET new Blazor WebAssembly hosted, and that'll be fine. So this will have 3 projects. We'll have the client, which will be the Blazor WebAssembly front end. We'll have the server, which will be our ASP.NET Core backend, and we'll have this shared project, which will be shared types and logic between the client and the server. We'll go ahead and run that. So if we want to launch this, we'll launch it from the server project. So we can just go .NET run. And let's have a look at what we get in terms of the samples out of the box. Okay, Control click on that. Here we go. So you can see we get an amazing Hello World page, and you can take a brief survey if you like and tell the team how Blazor's working for you. We get the classic counter example. We can count to our heart's content as long as we stay on this page. And we get the fetch data demo, which is pretty cool. It's a demonstration of fetching data from the server. So in this case, our ASP.NET Core API. And this is a random forecast. So every time you come here, you get some random results. Let's have a look at the source code too. If you want to work with Blazor on .NET 6, you probably want to install Visual Studio 2022. Let's see what the latest version is. They updated it this morning, so I'm pretty sure I'm on the latest. Yeah, so version 17, preview 6. You can go ahead and grab that. So as mentioned, we've got 3 projects here. We've got the client, which is the front end or client-side Blazor WebAssembly app, which is this one. Then we have the server, which is the backend or server-side ASP.NET Core application. And then we have the shared folder, which is logic and types to be shared between the client and server. Let's dive a little bit deeper into this because we know kind of what this is, right? It's almost just a class library. And we know what this is. This is an ASP.NET Core backend with controllers and a few Razor pages. But in here, we've got the Blazor WebAssembly app. So we'll dive in a little bit there. We have the www root folder for our static files. It contains CSS files, the favorite icon, index.html, which is the main template for our site, and a few things like that. Next up, we've got our app component, and this one is the root component of the Blazor WebAssembly application. We've got our shared folder, which includes shared Razor components. And I just like to keep the components that are shared across the whole site rather than components that are specific to a feature. We have the, let's see, we've got the pages folder, which by convention typically just includes routable components. We'll talk about that a little bit later on. And something Adam mentioned, we have the imports.razor, which is kind of our kind of using statements specific to this project. It's specific to this project because it's at the root level of the project, but we can create multiple imports files. And if we wanted, say, imports that were just specific to this pages location, it would apply to everything under pages, which is kind of useful, especially when you're building out features and they have a specific feature folder. So let's see. So we'll have a quick look at those 3 components. We have the index, which is the home page. It's quite simple. Generally, a Razor component has some directives at the top, some markup, and sometimes some code underneath. The counter component has all 3. So we've got our directives, our markup, and our code behind. And finally, the fetch data component, which is actually specifies a new using statement, we wouldn't really typically want that there. We'd go ahead and whack that straight in imports. We're going to be referencing those files a lot, so we can drop that out. And then we're injecting a service that'll be supplied from dependency injection. And there's our markup. And down the bottom, of course, we've got our code behind, and we've got an on-initialized kind of page lifecycle event. And in that page lifecycle event, we're making a call to the back end to grab some weather forecasts, loop through, and display them. So you can see that it's simple to get started, and that the sample code provides some basic examples, but it's not enough to build a real app. So in the following demos, I'm going to upgrade this template. I'll demonstrate state management, API access, data access, file organization, and more. And I'll provide you with a sample repo. So hopefully you have everything you need to build a real app. So let's go to the next demo, which is the counter upgrade. So in this demo, we'll explore techniques for managing component state and app state by upgrading the counter component. Let's have a quick look at the current implementation. So let me just make sure I didn't mess anything up there. I think we're good. Right. So we'll Control F5 this and see if we can get the new .NET 6 hot reload experience working for us. I found that it works best if we just start without debugging. So we've got a hello world here. Let's see if we can change that over. Hello. There we go. So there we go. So the hot reload experience is quite nice. Some of the times it doesn't quite work how you expect, but it'll actually let you know if something's going to be kind of required for an update. Let me see if I can trigger it. I'm sure it'll come up as we code. So this is the counter component. And if I go to the counter component, I can click on this button and increment the counter. That's amazing. If I click on that and go back, I've lost my current count, which is greatly disappointing because I've lost all of my progress. Those 7 clicks have gone forever. So in this demonstration, let's start by adding some app state so that we can actually keep the value of the counter component while we're using the application. So where will we start? We're going to build a new component, which is going to be a special one. And we're going to call it app state. So we'll pop it here, app state dot razor. And with this component, we're going to use something called cascading values and parameters. And they provide a way to pass data from component to all descendant components without having to use traditional component parameters. So let me grab the code for that so we don't have to type it out by hand. You can see I've got a cascading value, and you can specify a property here. But in this case, I'm specifying this, which is the actual app state instance. So that's what's going to get passed down to descendant components. And you're probably wondering, well, what are these descendant components that we're talking about? Well, let me show you. We've got over here in, let me see, in app where we kind of bootstrap our component. We go ahead and wrap that up. Let me just grab that code. There we go. So app state will become the root level component, and everything else will be a descendant. And so that means that the cascading value will be available to all components under app state. And so if we wanted to access that cascading value, we can go ahead and define a cascading parameter. So this is a good example. This is what I was talking about before. It's saying, hey, hot reload can't automatically apply your changes. Do you want to rebuild and apply your changes or continue editing? And you can just check this box, and for the entire session, it will do that automatically for us. So we won't have to kind of manage it. Hot reload will work its magic if it can. Otherwise, it'll be .NET Watch working behind the scenes, helping us out. I believe it's .NET Watch. Okay, so we've got our app state set up, but let's have a look at what's in app state. Where'd it go? They just shared, there we are. So it's quite simple. It's render fragment called child content, which is basically everything that's wrapped in app state. So in this case, it's the router and the main layout. And then we have a backing field and a property. This is not an auto property because when the current count has changed, we want to notify the app that it needs to re-render. So we go ahead and call state has changed. So with that in place, let's wire up the toolbar to display the current count. So in this template, I think it's in main layout. Yeah, we have this little toolbar. At the moment, there's just an about link to learn more about ASP.NET Core, but we'll go ahead and pop in a little span, and we will display the current count as it is set in appstate.currentCount. And it's complaining about that because it doesn't know about appstate yet. We have to define a parameter. So we'll go ahead and add a code block, and we say this is a cascading parameter, and we'll set a property for it. Whoops. Oh. I don't. My shortcuts aren't working, which is terrible. But that's okay. I think I'll be able to manage. We'll just make it private appstate get. All right. There we go. So we've got the cascading parameter. So that should sort itself out. It's complaining about the nullable implementation. You know what? I'm not going to be using that for this demonstration. So I'm just going to go ahead and get rid of them. So I don't have squigglies. Not recommend that practice just for the purposes of this demo. All right. I did get rid of the right ones. Yeah, that's good. Oh yeah, the other thing that you saw in there, right? Implicit usings. So by default, with a lot of the new templates, it comes enabled, and it'll be the default experience. But if you're working on an existing project upgrading to NET 6, you'll want to go ahead and enable it. All right. So we have the cascading parameter. It's getting the value of app state that's being passed down to this one because the main layout is a descendant of app state now. So if we go over here, we can see the current count is 0. If we increment this, nothing's improved because we haven't actually wired up the counter component. So let's get that done nice and quickly. So we're going to go ahead and add another cascading parameter here, which is obviously the same one. Do prop this time? No, okay. But app state. Okay, we won't need that anymore. That's our local component state. It wasn't providing us with a great deal of value. Let's see. Yeah, that's fine. So we'll go appstate.currentCount is what we'll display. And here, of course, we can just increment it as normal because we defined it as a property. Let's have a look. It's doing the rebuild for me, so I don't have to worry about it. And now if I increment the counter, it's incrementing in both places because it's using that app state. And of course, the state has changed method is being called to tell those relevant components to re-render. If we navigate away and come back, all of our work is not lost and we can continue where we left off, which is spectacular. And it's a good experience, but if we were to go and refresh the page, which our users will often do, they'll lose that value because that value is just being stored in browser memory, and they're going to be as disappointed as I am as to having lost those 20 clicks. So let's go ahead and update this a little bit further, just to store the value of the current count in session storage. So we have two kinds of storage that we could use. I mean, there's a lot of different storage, but say if we're talking about HTML5 APIs, we've got session storage and local storage. Session storage just applies to this browser tab, and local storage applies to the site that you're accessing. So in this case, I'll use session storage because if I open up two counters in two separate windows, I'll be able to increment independently and get a lot more done on separate tasks that way. So to get this started, we're going to add some JavaScript and do a little bit of JavaScript interrupt. And I'll also show you a nice package that you could use too that does a great job, but it's good to explore interrupt a little bit. So we're going to create a JavaScript file in our static files here, and we'll call it scripts. And then we'll call it blazordemo.js. Okay, I'm not going to type the code out by hand. So we've got this little Blazor object that we're initializing to be empty, and then we're attaching some methods to it. So we've got JavaScript object. So we've got get session storage, which takes a key and uses the session storage API to get the item given that key. And then we've got another method, set session storage, which will take a key and some data and store that for us so that we can retrieve it later on. So with the script in place, we need to update app state to load and save the counter value from session storage. So in order to do that with .NET methods, we're going to be injecting, typically we would inject the IJS runtime, but a better approach is to actually inject, sorry, I should clarify, a better approach when you're working only with Blazor WebAssembly is to inject the IJS in-process runtime. Because with Blazor WebAssembly, we have direct access to JavaScript. We're not, the code isn't running on a server communicating over the network via Signal R. We're right there running on the client. So if we want to run this synchronously, we can. So let's go ahead and inject the IJS in-process runtime. Okay. Now, if we do this, sorry, let's call that JS, it's not going to quite work for us because while IJS runtime is wired up for dependency injection, IJS in-process runtime is actually acquired by downcasting from IJS runtime to IJS in-process runtime. And so if we want to wire it up with dependency injection, we can do that. We can go over to program.cs, which is where we wire up our services for our Blazor front end. And you can see we've already got one service wired up out of the box, is the HTTP client, and it's specifying the base address for that client, which makes our life easy. If you're wondering where the base address comes from, it comes from index.html, and it's the base href. So that's a very nice approach to take. So we don't have to worry about that for any of our future services. So if we want to make the IJS in-process runtime available, we can simply wire it up with dependency injection, and we go ahead and use the service provider to get the IJS runtime and cast it to the IJS in-process runtime. And now we'll be able to inject it into our counter page. So with that in place, we can go ahead and update our, sorry, this is not where I want to inject it. I want to inject it into app state. So we're not going to be doing it there. There we go. Okay, now we can go ahead and update this page to load and save the state from session storage. So if we want to load state from session storage, we can use the onInitialized method or event. And we can do it quite simply like this. So we're overriding onInitialized and we're calling js.invoke, so synchronous. And we're saying that we're expecting to get back a result of type string. And then we try and cast that into an integer, which is the current count. I wonder if, can I just put it as an int and will that return null? No, that won't work. I'm just thinking out loud there. I've been working on this presentation for a little while, still running through my head. All right, so we go ahead and get that from the session storage, but I don't quite like this. I've been reviewing a lot of other Blazor open source projects, and I've been learning quite a lot from those projects. I recommend you do the same. So one thing that you could do inside of, say, shared or somewhere else in your application, create a JS. I think actually I've got a reference here that I can just use. Yes, we'll use this instead, typing it out by hand. So we'll go JS interop const .cs. So we're going to pop that in there and we'll implement it like this. So you can see I've got basically this constants class, so I don't have to use my magic strings to access the JavaScript functions that I'm trying to access. So you can see I've got this function prefix, Blazor demo, and that lines up here with this prefix. And then I've got the two methods. So get session storage and set session storage, building on the function prefix. This one's private, but the other ones are public, so it makes it quite easy for me to use those. So if I come back over here, I'm going to replace this nasty magic string with JS interop constants dot, and here we want to get session storage. We can replace this nasty string with name of current count. That's a little bit better. I like that approach better. Okay, is it okay? Is everything okay, Blazor? I think so. Okay, good. So on initialized, we're going to load the current count from session storage. And that's nice and easy. The other thing that we want to do is anytime that the current count changes, we'll go ahead and save that to session storage. And so a little bit of code here to do that. And it's going to be this one, but we'll go ahead and update it again. So JS interrupt constants. Wondering which project I saw this source code in. And it's not quite exactly the same. I customized it to suit my purposes. It was in Blazor. They have a lot of really solid code in there, worth checking out. So set session storage, and then we'll go name of current count. There we go. That looks pretty nice. So if we load this component, it will grab the current count from session storage. And when we update the current count, it will save it to session storage. Now, this is a simple example. You could also save an entire complex object because we're just using serialization, converting the object into a string and storing it in session storage. So this is a decent approach. So we'll go ahead and save those changes and let's see if it's working. Okay, it is not working. I know why. I've run into this issue about 3 times, but I'm never going to learn. So this Blazor demo.js file is not being referenced, so we've got to go and pop it in here. So, oops. Save. Does it refresh that? No. We'll do it this one time. Okay, incrementing, and here we go. Control F5. There we go. So it's still there. And if we want to have a deeper look, we can go over to the application tab here. Have a look at session storage, and there it is, current count. Bang. Nice and easy, right? Okay, so I mentioned that there was a another project that you could use if you wanted to work with these storage mechanisms. Now, I got to remember, it was Blazor storage. I was talking to someone about it today, and we reviewed the source code because I wanted to make sure that if I was using Blazor WebAssembly and I wanted to use the JS in-process runtime instead of just the JS runtime, that it was going to be able to do that. So yes, this is the package, and it's quite easy to wire up. It looks like it has a lot of settings that you can configure. And then when it comes time to use it, let's see. There we go. Await local storage. So obviously we're injecting the iLocal storage service. We await local storage set item async. So that's the asynchronous method. And if we look at the code behind that, that'll be using the IJS runtime. And it says here, if we're using Blazor WebAssembly, you might like to use the isync local storage service. And then we can use the synchronous method, which I've heard is about 4 times faster than the asynchronous method, just because of the overhead of the approach to support both Blazor Server and Blazor WebAssembly, which are fundamentally quite different. So there you go. This would be a good package to check out, and definitely worth reviewing the source code there to help improve your understanding of Blazor. Okay, so that's it. Using cascading values and parameters with JS interop and session storage, we can now retain the state of counter for the entire browser session. And as promised, if you want to get twice as much work done, we can go ahead and duplicate this tab. And let's a little disclaimer, I'm not using Windows 11, so I don't have these nice new features. I understand from Adam that I'm not a real developer. I'm very sad, but I will work on that. So let's see. There we go. So we're incrementing our current count here independently of our current count over there, just because we chose session storage over local storage, which can be nice. Sometimes when you're building out these features, the user might say to you, I want you to remember my filters, for example. And so you remember the filters for them, but you use local storage. And then they do this sort of thing where it's side by side and they go, hey, my filters from the other tab is overriding the filters on this tab. I don't want it to do that. Well, that's when you switch to session storage. All right, let's move on to the next demo. This is a good one. Fetch data upgrade. It's time to update the fetch data component. In this demo, I'm going to add support for OpenAPI, including Swagger UI. And then using the generated OpenAPI specification, I'll generate strongly typed C# clients for use in Blazor WebAssembly. So let's start with a quick review of the fetch data component. Jumping in here, fetch data. Okay, so as before, we've got our directives, we've got our markup, and we've got our code behind. We don't need that anymore. So the markup's pretty simple, right? This is Razor. And it says if the forecasts are null, just display a loading message because we're probably still loading. Otherwise, display this table and all of the forecast data that we have available. Simple for each loop. Now in the code, we have this private kind of field available, which is an array of weather forecasts. When the component is initialized, we make a request to the backend to get the weather forecast from this endpoint. And we cast it to that type, which matches this type, and we get the forecast back, and that runs as expected. We've seen that running, but let's have another quick look. Fetch data, random information coming from the server. And if we do a quick refresh there, you can see there's the request to weather forecast, and here's an example of the data being sent through. Okay, so it's hitting the backend API. If we have a look at the forecast controller, we can see, yes, it has a get method, a get action. The route has been customized to just be the controller name. So it'll be just this part of the controller name, weather forecast, and it will go ahead and generate some random weather data for us. Now, this is a small component, but really there's a lot of things that are wrong with this approach. Firstly, we don't really have a way from the code here to understand the capabilities of the API. We have to specify the route using a magic string that can break, and we even have to specify the return type. A lot of things can go wrong with this. It's not really easy, especially if you have two separate teams, one set of teams working on the front end, one set of teams working on the back end. It's going to happen less with Blazor, right? Because we're all just writing C#. But we can certainly improve this with a few small changes. So let's go ahead now and implement OpenAPI. And I'll do that using my favorite OpenAPI toolchain, NSWAG. So with NSWAG, we're going to be installing some packages on the server project. So from the command line, .NET, add package nswag.asp.NET Core. And then we're going to install NSWAG MS Build. So NSWAG ASP.NET Core will provide us with the services and the middleware in order to display Swagger UI and generate an open API specification at runtime based on ASP.NET Core's API Explorer. It's really easy to use. So did I install MS Build? Yeah, we got MS Build. That's good. So we use the MS Build project or package to automate the whole thing. And by automate, I mean, when we build server is typically if we've changed a controller or an action, we'll need to regenerate the OpenAPI specification and later on the clients that we're going to create. And so we'll automate it by using an MS Build task to run NSWAG after Blazor demo.server is built. So let's fire it up so that we've at least got an OpenAPI specification and so that we've got Swagger UI. So if we go into program.cs, we can start by saying, let's see, this is the new minimal template, right? So we don't have really anything in here. Startup's gone, program.cs is gone, our namespace is gone, our methods are gone. They've taken everything from us and left us with this comment. So we know to add our services here, and we've got this comment. So we know to wire up our middleware here, okay? But don't go past here and don't go past here because you've gone too far. We need a comment, stop adding services here. All right, so we want to wire up OpenAPI. So we go builder.services.add OpenAPI document, and I like to customize this a little bit. And I just want to give it a title. So we'll go configure title equals Blazor demo API. There we go. So what did that do for us? It just added the services necessary for us to work with NSWAG. Not much really. So now we want to add some middleware. We want to configure the HTTP pipeline. So we can do that first by saying app.use OpenAPI. You know what? Let's just start there. Let's see what we get with that. Fortunately, we've got everything kicking over nicely in the background, so we don't have to worry about anything. We just have to be patient. And we come over here, and nothing's changed here. But if we go to /swagger /v1 /swagger.json, we can look at our OpenAPI specification. And so you can see it's being generated automatically for us by nswag. And if we scroll down, it describes the operations, the inputs and outputs for the operations, and any specific types, such as the weather forecast type. So we can now use that OpenAPI specification to display something like Swagger UI. And to do that with nswag, we can just say use Swagger UI 3. Save that, and I made a mistake. Did I? Okay there. What's happening here? It's all going down. That's okay. We'll get it back up again. Use Swagger UI 3. No, there's no mistake there. That looks good. We'll go ahead and refresh this. So we've got that specification, and it's worth noting that specification is being generated at runtime each time. Okay. And so now if we go to /swagger, we also have Swagger UI. So we've provided this really cool mechanism for our developers to explore our API. So if we go into get weather forecast, we're going to try it out, execute, and get the results back. Easy, right? It's not really about that though. It's about what we can do with that specification. And what I love to do with the specification is generate strongly typed clients, whether it's for Angular, Vue, or React, or in this case, Blazor. So let's have a look at how we can do that. First thing, I don't want to generate the specification at runtime. I'd prefer that we generate it on build using that MS build task. I really like to see the specification actually as part of my project, as a file in my project, so that I can see when it changes. When I go to check in changes, I can see that. And also, it's one less thing that I have to do on my Azure DevOps pipeline. So, if I'm generating it manually, I don't have to run it because I check in those changes. So let's see. I want to store the specification in WW root. And yeah, let's just get it done. So to do this, I'll use a tool called nswag Studio. And nswag Studio is not really geared yet for .NET 6, and in a moment we'll see why. So I've created a new configuration here because the nswag Studio is a nice big configuration editor, so that we don't have to edit the JSON configuration by hand, which certainly makes life easier. I'll go ahead and save it straight away. I'm going to put it in, where did I put it today? Demos, Blazor demo server, because that's where we're running our nswag from. So we could go ahead and call it nswag.json. That's pretty typical, but I like to call it config.nswag. The reason is that with the nswag extension, I can double click that and it'll load up nswag Studio, which is kind of nice. So there we go. We've got our new configuration saved. Now you can see from the available runtimes, it only supports up to .NET 5. Now that's going to be fine for our purposes, but it just goes to show nswag has not yet been upgraded to support .NET 6. So the preferred method is to use ASP.NET Core via API Explorer. That'll tell us everything we need to know about our API. You can see we need to navigate to the project file path. So I'll go ahead and do that, which is this one. And we have this option, no build. Now remember, I want to run nswag after the server project builds. So I don't want nswag to then build a project again. So we'll check that. Scrolling down, I want to put an output file path. Now, we know that the convention is swagger /v1 /swagger.json, but I don't think that's a very good convention. The reason is that it's not called Swagger anymore. It's not the Swagger specification. It's the OpenAPI specification. So I'm kind of going my own way on this one, and we'll put it in an API folder. I like that because it kind of matches the default route that I'll use for my APIs, /API. And then we'll create a folder to support the version, v1, that's good. And then we'll create a specification file. Instead of calling it swagger.json, I'll just call it specification.json, and that'll be fine. One thing you'll note is that we have these hard-coded paths here. If I save that, and we actually have a look at the configuration file, just over here. Oh, yeah, that's the only problem with making it that. I have to sometimes, I will just open it with Visual Studio Code. See, it automatically opened it for me in NSWAG Studio. If we save that, you can see, where's my output file path? It's usually down the bottom. Oh, there it is. It's relative. Okay, so if someone else checks out the source code, they're not going to have a problem because they've put it in a different location on their drive. Okay, so we have this first part of the configuration built, and the first part of the configuration is for our OpenAPI specification. We can go ahead and test that out now by clicking Generate Outputs, and it fails, which is always fun. We're with NSWAG, until you have some experience, sometimes these things can be a little bit hard to debug. Fortunately, I know exactly what is wrong here, and here's the message we're looking for. NSWAG requires the entry point type program to have either a build web host or create web host builder / create host builder method. So what does that mean? It means that NSWAG currently does not support this new minimal program.cs. It misses the methods that were available in program.cs. So I've tried a few different approaches to work around this. And to be honest, my preferred approach is just, while we're in this transitionary period, because I'm on RC2, it's just to bring back startup and program.cs, because the fact of the matter is that with .NET 6, the templates include this minimal approach, but it's up to you to use your preferred approach. You're not locked into this. So if you want to do things a little bit differently in your project, then you can go ahead and do that. There is a bit of a problem though. If all of the templates ship with this minimal approach, it's pretty much going to become the standard approach, and people will forget about the old approach. So it's a problem for now, but later on, not so much of an issue. We'll see how it goes. Anyway, we're going to revert this back so that we can have the really nice experience with NSWAG, the OpenAPI generation automation, and the C# client generation. So to do that, we'll go ahead and move everything into our startup.cs. And inside of startup.cs, I've leveraged the nice namespace without the extra level of braces, and it's pretty much the same. The only thing that is different is that I've gone ahead and added use static files, because our OpenAPI specification is actually going to be stored in WWRoot, which is the static files for the Blazor demo.server project. Everything else is the same. So we just need to update program.cs now. And it will be just like that. So this is the method that NSWAG was looking for that it couldn't find. So if we save those changes, and if everything ticks over nicely, we'll be able to run NSWAG Studio again and see the generated specification. So that's great. We've got NSWAG working with .NET 6 RC2 to generate an OpenAPI spec. Now I want this to happen automatically, as I mentioned. So we'll update the Blazor demo.server CS proj to run NSWAG after build. So you can see here we've created a new task called NSWAG. It's going to run after build only when the configuration is debugged. So it's only going to happen during development. It's not going to happen as part of our DevOps pipeline. You can see here, where is it? The command will be run NSWAG. Sorry, the command will be run the .NET 5 version of NSWAG, and the command will be run and use the current configuration, which will be locked to development just because of the environment variables that have been set here. Now you notice that we haven't specified a configuration file such as config.nswag or nswag.json. You don't need to. nswag.json is the convention, and config.nswag is a recognized convention as well. So if we build this project now, we should see NSWAG output happening in output here. Try that again. Build. There we go. So NSWAG command line tool for NET Core 5, it ran, and look, WWRoot has appeared. API v1 specification.json. So that's now being generated automatically for us, which is great. Okay, so now that it's been generated automatically, we don't want to generate it at runtime. So to get rid of that, we can just drop this app.useOpenAPI. That brings us to a problem, which is now that we're fighting against the current convention, swagger/v1/swagger.json, we have to use configuration, at least until my convention becomes the, until my convention becomes the popular convention. Yeah, document path. And I'm bored of typing that in now. So we'll go equals, there we go. Okay, so we can see here that we're setting the document path to reference our specification, which is matching up to this one. So if we go ahead and save that, everything's going to tick over nicely for us. And if we come to Swagger UI, just have to get rid of this. There we go. We can see that it's pointing to API v1 specification.json and everything's working as expected. Otherwise, we wouldn't even see this. All right. It's behaving normally. And of course, we can access that specification in the same way that we access the other one. Yeah, just at a different location. If you're wondering why this looks so nice, it's the JSON viewer extension for Chromium browsers. Okay, let's see. Now we're going to build the C# strongly typed client. And to do that, we'll update our configuration in NSWAG. So C# client, we check this tab and we go to settings. We have to specify a namespace. The namespace we're using is Blazor demo. I wonder. I could change that namespace, but we'll leave it for now. Blazor demo works, even Blazor demo.client. We also want to bring in some additional usages. Why do we want to bring in usages? Well, in the past, when we would generate these clients, say a TypeScript client, we would actually generate the associated DTOs. So you saw in our specification, we have this weather forecast object. So we would generate a TypeScript version of that. That version would live on the front end. And of course, the C# version, the source of truth, would live on the back end. And we'd use NSWAG as a way to keep them in sync. So we had a single source of truth, and we weren't violating the dry principle by maintaining those two matching types independently, which we would typically fail to do anyway. But we don't need to do that anymore. Remember, our client and server are sharing the same code. It's right here. So we don't have to generate those types, but we do need to reference the namespace for the generated clients. So we can just go ahead and put Blazor demo.shared or anything else that we need. We could also, which is something that I've got to do next, is have a play with global usings. Maybe we don't need to add any additional namespace usages. And that has its own benefits, but I'll save that for another day. So we've got our namespace and our Blazor demo.shared. We're going to generate our client classes, which will be our client classes that will depend on the HTTP client to make requests to our backend API. I like to uncheck this option because the base URL has been set in the HTTP client. We saw that before, right? So when we looked at the client over here, and we saw how in program.cs, HTTP client was wired up with a base address. So we don't want to have to specify it for these generated clients. They'll just use this. What else have we got? I like to generate interfaces. Where is that? Generate interfaces for client classes. That's handy. Scrolling down. Wait, did I pass it? No. Here it is. Generate DTO classes. Pretty happy to be able to uncheck that. It's really nice to have that C# code in the shared project accessible on both the front end and the back end. And now we just want to specify an output file path. Let's see. We're outputting this to the client. So there's our client project. We're going to put it in a services folder. And I like to call it Blazor demo API clients.g.cs. So G for generated. I don't know if that's a good convention. It's just something that I started doing recently. So let's give it a try. Generate outputs. Cool. There's our client. Right up front, we have our weather forecast client, our interface, and it has two methods, get async or get async with a cancellation token. Nice and simple. Underneath that, we have our implementation. I'm not really wanting to dive into the details. So let's just go ahead and save and continue. We use NSWAG on pretty much all of our projects, and the clients that they generate are really great. We haven't had any problems with them in production, whether it was TypeScript clients or C# clients. One thing to note is it's powered by these liquid templates, and if you do need to go ahead and modify your template, it's really easy to do. It's really easy to include it in your project, and quite a nice experience overall. So don't be afraid to dig in a little bit deeper. But there's many extension points here as well. If you wanted to specify base class, that sort of thing, you can do that. Anyway, I think we're finished with NSWAG Studio now, so we'll go ahead and close that down. And let's do a build on our project and see if we get that generated C# client. Nothing much happened there. That's because I guess it doesn't recognize that anything's changed, because all we did was change that configuration file. So we'll do a rebuild here on server, and it looks like it's got some complaints about nullable reference types, but NSWAG ran successfully. And over here, we've got our services folder and our new Blazor demo API clients. So that's great. We'll run into one problem here. It's that NSWAG, the templates that are currently being generated, use newtonsoft.json. Okay, and so that's not in this project by default. Now, they are working on, I shouldn't say they, I guess Rico is working on system.text.json, but the support for that is experimental at the moment. So let's stick with newtonsoft.json, which we all know and love. So if I jump over to, wait a sec, where am I? Yeah, that's the right place. Over to client, and we'll go ahead and .NET add package shift insert newtonsoft.json. That'll sort out that error for us. Great. Let's do a build. Solid. Let's update fetchdata.razor. Okay. Where is it? Here it is. Fetchdata.razor. So first thing we want to do is inject. You know what? We're going to get rid of HTTP client. We won't need that anymore because we didn't want to use that at that low level anyway. We'll inject our weather forecast client, and we'll call it client. Save that. What's the complaint about? HTTP. Oh yeah, of course, because I made some breaking changes. So there's our weather forecast client. It's been injected. Over here, we have our call to the HTTP client. We'll just comment that one out for now, and we'll make our own. Forecasts equals await client.getAsync. And that's it. Right? Much simpler. We have a strongly typed client. We're able to kind of explore the methods that are available. Admittedly, there's only two, really one with the cancellation token overload. But as any complicated app builds out, you'll be able to go client dot, and you'll be able to see all of the different methods that are available and understand the API a little bit better, easily understand the return types, and build your app to suit. We can get rid of that. One last thing, we're injecting this, but it's not wired up. So let's go back to program.cs, and we'll go ahead and call builder.services.add scoped weather forecast and that one. There we go. So anytime we add a new controller with actions to our API, it's going to generate a new client, and we'll come in here and we'll wire up that client, after which it will be available for use. So if we go now to our weather forecast client, well, we should be ready to take it for a test drive. So we'll control F5. It's the best experience. Don't worry about that. Fetch data, and it works. Okay, so we're still getting our data back from the server, but now it's using that strongly typed client, which is a much nicer experience. If we were to make some kind of breaking change, we're going to be able to detect that really easily as well. And that's one of the things that I love about this approach. So if we remove an action or change an action in some way that breaks our client, we'll find out very quickly. So let's get ABC. It's doing this little rebuild. That's nice. Back over to our fetch data. Just wait patiently. There we go. It says, hey, there is no get async method. So if we try to build that, because this C# code has just been generated, of course, it's not going to build any longer. So that's great. We can go ahead and explore it and figure out exactly what went wrong and fix it. So that's nice. Breaking change is really easy to detect, which is just one of the best things about this experience. So awesome. I'd like to give you a quick win. You know, when I'm building my client applications like this, single page apps, I always love to have a global loading bar, and that loading bar typically reacts to any HTTP requests. And so I found a nice little package that we can use for that. So let's put that in. So if I go Shift Insert, yep. .NET add package toolbar.blazor.loading bar. You don't have to remember any of these resources because I'm going to share with you all of these resources and more towards the end of this presentation. So go to program.cs, and now we've got to wire up the services for the loading bar. First things first, this uses a kind of interceptor for the HTTP client. So I might just clean this up a little bit so it's easier for me to see. Enable intercept. I think that's right. Yeah, there we go. Using toolbar.blazor extension dependency injection. And we just pass in the service provider so it can do the wiring up for us. And then we're going to say add the service for the loading bar. So we'll say builder.services.add loading bar. Straightforward. And then finally, we need to add the loading bar itself. So we can just say builder.use loading bar. And we can specify a few different things. There's a few methods there, such as the color of the loading bar. But I find that the default color is pretty good for these demo purposes. Okay, I think that's it. Oh yeah, we do have a problem though. This weather forecast sample, it generates the data in milliseconds, like less than 100 milliseconds, it's just not right. Weather forecast data takes time to generate, and it takes time to retrieve it from the server. So I want to make this task a little bit more realistic. So first we'll make it asynchronous. What am I doing there? That's better. And then we'll add in an appropriate delay. Fast start. 4 seconds ought to do it. There we go. That's going to be much nicer. That one's finished. So we run this. So now when we retrieve our weather forecast data, we know we're going to be getting the freshest weather forecast every time because we can see that it's taking time to do that. And we have this little loading bar up the top, just lets us know that the page is working on something. So that's really nice. So we're going to get that for all of our HTTP requests, which is good. I like that approach. And later on, you know, we can add some additional interceptors, perhaps ones that handle globally. I say globally for the client, any common HTTP errors that we might get out of those requests. So we can add another. Sorry, I want to be on program.cs. We can add another interceptor to, you know, display a toast to say that request to the server failed. Please try again later. That sort of thing. So that's going to be nice. All right, on to the next demo. So now we're going to do the to-do app. Now, I know some of you are sick of seeing to-do app demonstrations, but to be honest, I don't know how you get things done if you don't have a great to-do app. I'm always working on improving my to-do app, and this one is exceptional. In this demonstration, we're going to talk about conventions for organizing components. We'll talk about the current conventions and convention I think people should be using. We'll talk about separating your markup and your code by using code behind. And we're going to talk about the ultimate approach to validation for Blazor WebAssembly, so client and server validation. Let's have a look. So I've got to switch to a different project. That's as far as we'll go with the section. Let me close that one down, and we'll clean up a few windows. We'll keep it simple, right? So here we are. This one is the same. It's just got the to-do app demo because I didn't want to build it from scratch because it takes time to build a quality to-do app, right? Blazor demo solution. Here we go. So the focus is not so much on how I built the to-do app, but more so on how I organized it, the code behind, and the ultimate validation experience. And one more really cool thing, which I'll save to the end. Okay, so inside of Blazor Server, we've got some controllers. We've got to-do list controllers, to-do items controllers. Inside of shared, we have our entities, our to-do item, our to-do lists, and states and priorities, all the bits and pieces. I'll be sharing this repo with you, of course, so you'll be able to explore this at your leisure. And in the client, we have our to-do app components. Now, I want to start by just discussing the conventions that you get that are kind of proposed out of the box if you're having a look at the Microsoft documentation. So we have this pages folder and this shared folders, and we use those two folders to organize our components. The convention is that we'll put our routable components inside of the pages folder, such as index, counter, and fetch data, and our shared components, our non-routable, reusable components, our building blocks inside of the shared folder. And I've tried, if you've worked on my development team, you know I've tried many different ways to organize components. And if you worked on my development team, you're probably annoyed with how much I've changed things around. But happy to say that I've arrived at what I think is the best approach for me in terms of working productively on a feature. So what I like to do is to create a feature folder. And inside of that feature folder, I'm going to have a routable component, and it's going to be called index.razor, and it specifies the route to do, which matches the feature folder. So it's very easy for me to go to this directory and say, okay, this index.razor is going to be at the root of the site. So its route is going to match its location on disk. And I like that approach. It provides me with a logical way to reason about where to find the files and the routes that I would expect to be associated with those files. Now, instead of then going to shared and creating a to-do folder and putting all of my shared building block components inside of that folder in shared, I keep them right here. So this is no longer just routable components, it's routable components and feature components, these to-do items, to-do list, and to-do state, all contained within the one directory. Because look, if I create a to-do folder over here, I'm constantly jumping back and forth between the two to build out this feature. In this approach, I have everything in the one folder, so it makes it easy for me to work on that feature. Now, I also like to keep the C# code out and separate from the markup. It's really easy to make that work. If we have a look at, let's do the weather component here. We've got the client being injected, that using statement, which we got rid of in the other demo, and we've got the code for the component. If we go ahead and create a weather.razor.cs file, it'll mess it up a little bit. But if we delete that, we've just got a weather class. And if we change that to a partial class, that will now be the code behind for this Razor component. And it's a partial class because behind the scenes, it's generating a class anyway. So let's go ahead and grab this code and pop it in over here. Let's go ahead and grab these statements. I'm in here. And instead of using the @inject directive, we'll use the inject. Oh yeah, it is it. Phew, I was worried there. Okay, that's looking good. Over here, we've got just that one directive for the route. And we don't have any code behind, so we're just focused on our markup and a little bit of that Razor syntax. So I prefer that approach. Oftentimes when I'll be developing on a component, I'll actually put them side by side. So then I can see my markup, I can work on that, and I can work on my code behind, and that's quite nice. Of course, there are other approaches, and which approach you follow is entirely up to you. That's the approach that I like to use. And so you'll see within this to-do application, we've got code behind for all of those files. You'll notice that index.razor doesn't have any code behind, and that's because it's just there for the template, the layout. It's organizing the different components. So you can see for this particular feature, I have a to-do state. So that's a cascading value, and to-do lists, which have the cascading parameters. So the state is shared centrally here for both the lists and the to-do items. We should have a look at this demo. We haven't looked at it yet. So I might just start it up here. So we jump into server. And we go .NET, .NET run. Here we go. Okay, so I've got this URL, and I'm going to paste this one in. Yeah. Here we go. Here is the amazing to-do app. So it's not your regular to-do app, okay? We don't have a single list here. If we want to work with multiple lists, we can create a most important task list. We can go ahead and start adding items to it. It's an important task. Maybe drink a nice coffee. Load more that way. So coffee emoji. It's lollipops, but I get the point. There we go. So we have a very nice experience for creating lists. We can go ahead and create another one and say, no, we don't need that much work to do. So we'll go ahead and delete it. That's very nice. We've got our default data, and we can go ahead and mark things off and add new items. And yeah, works pretty well. So the purpose of this feature is to demonstrate all of those other things that we've been talking about. So we've had a look at the organization of the components, and we've also had a look at the code behind. But now I want to show you something which I think is really amazing. It's the validation experience. When I go to create a new list, if I hit create, of course it says title must not be empty. And that in itself is not amazing. But one cool thing about it is it's coming from Fluent Validation. And so if we look at shared, and I have this to-do list validator, I've got a simple little validator here that says the title must not be empty. And I also have a little package installed on the client. It's called Blazor.Fluent Validation, which provides really nice support for Fluent Validation in Blazor because it's not available directly from Fluent Validation. And if we have a look at this to-do lists modal, you can see the way it works is we're using the Blazor edit form, and we have this Fluent Validation validator. So a lot of times, you'll see the data annotations validator. Well, we're not using data annotations. We're using Fluent Validation validator, and we've got this little property here to disable assembly scanning, because if Fluent Validation validator doesn't find any validators, it will scan the assembly and slow up startup. But of course, I've wired those up in this application, so you can see here we've got this add validators from assembly containing, which comes from Fluent Validation. And so actually more specifically, it comes from Fluent Validation dependency injection extensions. Okay, so not the base package. So that's pretty important. So what it then does is just goes and grabs any validators that are in the assembly that contains this file type, or sorry, this class. It doesn't have to be the validator. It can be anything at all. But I just put it as a validator because it kind of makes sense. So at the moment, there's one validator, but it'll find any that are contained within that assembly. So we get that really nice experience. If you haven't seen it before, these inline validation rules, that's supported by Blazor as well. And so you can kind of see this validation message has been specified, referring to the actual property that could be in error. And so that's really nice. I'm not saying that's the ultimate validation experience because it's simply not. But look, you've seen this validator, and I want to show you something pretty amazing. If I now go and create a new MIT list and hit create, I get this message, and it says title must be unique. And you must be wondering where that's coming from, because in this validator, we don't have that. Well, typically when I'm building applications, I have a validation experience on the front end and a validation experience on the back end. Now, in the past, I've had to write the front-end validation experience in JavaScript or TypeScript, and I've had to write the back-end validation experience in C#. I use Fluent Validation on the back end, and whatever framework I happen to be using on the front end, whether it's React or Angular or Vue, now it's Blazor, and I'd have to rewrite it, and I have to try and keep them in sync, which I eventually ultimately failed to do, but they wouldn't always need to be in sync. Sometimes the back-end validation would do more than the front end. And so that's what I've done here. I've added some additional validation on top of this to-do list validator. And so if we go to the back end, where did I hide that? Over here. We have this validators folder, and there's a new to-do list validator. The difference between this to-do list validator, it's not implementing abstract validator. It is derived from to-do list validator, the one that is in shared. So when we create this to-do list validator, it gets all of these rules from the shared folder and the additional rules that we just want to run on the back end. In this case, we want a unique title. And to check that, we're going to go ahead and check the database. So now we have these validation rules that are shared on the front end and back end. And also we have this amazing experience where we're able to extend those rules for running just on the back end. And I really love this approach. I'm super happy with this. But there's one more thing. How did we get this new, how did we retain this inline experience, even though these errors are as a result of a 400? So if we go and have a look at the network tab and just run that again, we've got the problem details response, which we've all come to know and love, really the validation problem details response. And it's returning us this dictionary of type string with a key string and a value of string array. So how do we get it into a validation message? Well, it's this little component here. And I learned about this from the Microsoft docs. The Microsoft docs for Blazor are excellent, so definitely worth checking out. So this is a custom validation component, which is actually part of this project. So it sits right there. And I'm calling it a component, but you're probably wondering, well, why doesn't it end in .razor? And I thought about that too. Well, this is a component that actually doesn't have any markup. And it's a non-routable component, so we don't really need the .razor. But it is a component, just like any other component. You can see it's derived from component base. When we created our weather code behind, we didn't derive from component base because it's code behind. It's a partial class, but we can if we want to. And that's a good way to have a look at. That's a good way to have a look at some of the things that you get for free in component base, such as these lifecycle events and anything else that's available. And also, you might want to consider deriving from this class and creating your own component base for your application, because there's a lot of powerful things that you can do across the board, across the entire client app for your components to make your life easier, such as implementing focus or automatically injecting IJS in-process runtime or IJS runtime, those sort of things. So worth thinking about. But anyway, back to this custom validation component. So it has a property, validation message store, which holds all of the validation messages for an edit context. What's an edit context? Well, it's the context for this edit form. We haven't specified it directly, so we're using the default one. We've got a cascading parameter because this edit form was also supplying a cascading value, and the cascading value is the current edit context, which is great. So those cascading values and parameters are used throughout the Blazor framework, so it's worthwhile knowing. So then we have the override for onInitialized, and we're basically doing a little bit of sanity check, saying, hey, if you haven't supplied a current edit context, then you're probably using this in the way that it's not intended. So check all of these things and fix it up. Then we've got this message store, which we're basically creating a new validation message store. The type is specified on message store, and we're passing in the current edit context, which is what's required to create a new message store. We're clearing any validation errors. Sorry, we're not clearing any validation errors. We're wiring up the onValidation requested event from the current edit context so that we can clear any messages before validation starts. And we're also wiring up the on-field changed message. So when a user changes, say, the title on the form, it will go ahead and clear the message for them so that they have that nice validation experience where we're not constantly pestering them with these red error messages that are no longer relevant. So we've got some helper methods which are publicly accessible. We can call display errors and pass in a dictionary of errors, such as this dictionary of errors that we get back from this failed request. And you can see that we're simply wiring it up with the message store, and then we're calling notified validation state changed so that this form knows to re-render. And we've got this clear errors helper message so that we can clear the errors before we make a new attempt at submitting to the back end and receiving a response. Hopefully everything's okay once we get that second response through. So what else do we need to look at? I think that's it. I think we've covered it really well. So coming over to the to-do list code behind, you want to see all of that in action. We've got a reference to the custom validation component. That's so that we can access display errors and clear errors. And then when we go create new list, first thing we do is clear the errors. Then we try to create the list. This is where it's likely to fail. If it fails here, it's going to throw an API exception as per our generated strongly typed C# clients. If it does throw an API exception, it's probably going to have a response, which is of type validation problem details. So we'll try to grab that. If it's not null, then we can go ahead and display the errors which are contained within validation problem details.errors. And so that's how we get that super nice validation experience. And for me, that really is the ultimate validation experience as far as Blazor is concerned. I couldn't be happier with that approach. All right, what else are we going to cover in this demo? One more last minute thing that I added when I was making the final preparation for this presentation. So if we go to program.cs, you can see here we're wiring up all of these clients as they're created. We only have to do it once, but typically I forget to do it, and that gives me an error at runtime, and that's kind of annoying. So let's do it a different way. We'll delete that, and we'll use a package called Screwtor, which is installed. There it is there. And it provides a nice assembly scanning mechanism for us to scan our assembly that contains the iWeather client. It'll find all the classes in that assembly, and it will wire them up with the implemented interfaces with a scoped lifetime. So essentially, it's doing this automatically for us so that we don't have to do it anymore. So next time we create a new controller, that client is going to be automatically available for us. So we'll save that, give it a quick test before we move on. Actually, I wanted to run it through here. Oh, it's already running. Now I've killed it. Now I have to run. Never mind. Okay. Waiting. Awesome. Quick refresh. And look at that. Our clients are still wired up and still happening automatically for us, which is great. So we never have to touch that again. And that's kind of a whole big chunk of our application that we don't have to touch again. It's the open API specification generation. It's the strongly typed client generation. It's the wiring up of those clients automatically. We basically just write the code now. We put in the effort ahead of time so that we don't have to do that later. Okay, that's it for this demo. You probably think there's nothing left to upgrade, but you're wrong. There's one more thing we have to upgrade before we finish up tonight, and that's the homepage upgrade. We need to add some awesome resources. You know, in the past, these templates, they had a homepage that told us all about the template, and they had links to all the greatest resources so that we could go and learn how to build an Angular app or a React app or work with Razor pages. And I really miss that in this template. With this template, go back to the other project now. With this template, let's have a look at what we've got. So is this my Blazor demo? And working directory. Yep. We can shut that one down now. We get only the hello world experience. We do get a nice little survey though that we can fill out to give some feedback to the Blazor team, so that's great. And there is an about link here so that we can get some ASP.NET Core resources. But I want the original experience, the one that we had in .NET Core 2.1 and earlier. So I'm going to bring that back. So let's do that. And of course, I'm going to retrofit it with my own resources that I'm going to recommend, and another link that will give you every other resource that you might need with Blazor. So first thing we're going to do is put in a bunch of code. That should be nice. We'll close that down. And then I need to put in some scripts. You can look away for this one while I add this script for Bootstrap JavaScript. So, and now I think we're good to go. Let's give it a try. Not quite. We're close. We're really close. We just need some images because all home pages should have some great images. There we go. Drag that across. Okay. Quick Control F5. Still broken. What did I do wrong? Got the images. Bring it into the right project. Let's see. All that. Try one more time. All the demos to fail. It's funny that it would be this one, static content. Come on. Is it wrong? Yeah. There we go. So now we have the original experience, so we can learn all about Visual Studio, we can learn all about Azure, and we can learn all about ASP.NET Core. I've put in my own resources here. We've got the application. It's using sample pages using Blazor, theming using Bootstrap, icons using OpenIconic, OpenAPI using NSWAG, validation using Fluent Validation, and of course, data access using EF Core. I promised you data access tonight, but that's your homework. You're going to have to review the code to have a look at that. And if you're interested in building enterprise applications with Blazor, keep your eyes open because we'll soon be running a new clean architecture superpowers, which will have enterprise applications with Blazor. For resources, we've got building web apps with Blazor. So this is the blazor.net site. This is where you can come to get started. Even if you're completely new to Blazor, I wouldn't recommend coming here because there is this Blazor app building workshop. And the Blazor app building workshop actually will guide you through the entire process, including going to Blazor, getting started, getting set up, and building your first app. So I think you should just follow this workshop to get up to speed with Blazor. It's really great, and you can probably see why. If you look at the contributors on this, we've got a lot of great people who have worked really hard on this workshop to build us a really nice experience. And so, yeah, definitely worth running through this. So what else do we have on our new upgraded homepage? We've got Blazor on ASP.NET Core blog. So if we want to stay up to date, that's not it. Sorry, that's Blazor on Microsoft Docs. We're going to have to update that now. We need, let's see, over here, Blazor blog, that's supposed to be the blog. Yeah, okay. So the ASP.NET Core, or just the ASP.NET blog, has not that one. I shouldn't have searched here. This is for development. Okay, and if we go, yeah, oh yeah, there we go. Click on Blazor. That's the resource that we want. So we can see on the ASP.NET Core blog, the latest and greatest with Blazor and ASP.NET Core in general. So we can see the release notes, say for the .NET 6 release candidate 2, custom deployment layout for Blazor WebAssembly apps, just goes on. So that's where you're going to learn about the latest stuff that's happening. I think that's probably not right in the template. So I'll go ahead and I'll update that soon. So what else have we got? We have this great book, Blazor WebAssembly by Example. It has a lot of great content. I can't remember what my favorite parts of it were, but let's see. We've got I liked the JS interop section. I loved the progressive web app sections. The Kanban board was really cool. I've got to build my own Kanban board now. Yeah, that's a really good book, worth checking out. I think you can get it through a trial or $5 a month through Patch, so that's pretty cool. We've got Blazor courses on Microsoft Learn. So there's a couple there. This one's interesting. I haven't done this one yet. Published a Blazor WebAssembly app and a .NET API with Azure Static Web Apps. That's pretty cool. Back over here. This is an awesome resource. Carl Franklin's Blazor Train. You have to check that out. It's just video after video of all topics, Blazor WebAssembly, Blazor Server. It's just going on, and he's producing new content all the time. Very cool content. Something I saw today. Yeah, this error boundary, so I got to check that out. Okay, we covered those courses. Oh, okay, here's some of the packages we used today. Blazorize Fluent Validation, Toolbelt loading bar, and so Blazorize Fluent Validation is pretty cool. We use that for our Fluent Validation experience. There's some other Blazorize packages that you might want to check out. And then we've got the Toolbelt Blazor loading bar. There's another package that we used in a project here, which was the shortcut keys, I think. Let me see, 169 repositories. Wow. Let's search Toolbelt. Oh, there it is. That's the one I'm looking for. Toolbelt.blazor.hotkeys. This is a really cool repo if you want to add some hotkeys. You kind of think, we're going to add hotkeys to some kind of HTML element. Not at all. It actually wires up the hotkeys to the methods in the back end of your component. So it's a really nice experience. The next thing we want to do is kind of bring it up so that if you can press the question mark to bring up that really cool little modal that you saw to show what all the hotkeys are for the current component. There it is there. So that's definitely one to check out. With these Blazor component libraries, there's so many, and I think you might think we're just going to bring in something like AntBlazor or DevExpress, and we're going to be able to build Blazor apps really easily. And that's true. They're going to go a long way to helping you be productive with Blazor. But there's something else important. These component libraries, a lot of the open source ones, are amazing learning resources for learning how to work with Blazor. And the reason that they're amazing resources is because Blazor is component driven, right? Components are the building blocks of a Blazor application. And so no matter what you're building in Blazor, you need to get really good at building Blazor components. You need to get as good at building Blazor components as the AntBlazor team or the DevExpress team, because they're the building blocks. That's how you put together your application. So you'll be able to build good blocks with a basic understanding, but you'll be able to build amazing applications, amazing components with a really strong understanding. So I'd definitely encourage you to review open source projects, even if you're thinking, I'm going to build this component from scratch myself because I have specific needs. Have a look at what's happening under the hood with some of these open source libraries, and then build it yourself. You'll certainly learn a lot. I know I have. That's it for the resources. Let's jump back over to the summary. So in this presentation, we looked at modern web development with Blazor WebAssembly and ASP.NET Core using VS 2022. We examined techniques for managing application and component state using cascading values, parameters, and session storage. Using OpenAPI and the NSWAG toolchain, we added support for OpenAPI and strongly typed API clients. We discussed conventions for organization of components and files, and I shared my preferences. Using Fluent Validation and Blazor, I demonstrated the ultimate validation experience. And finally, I shared some amazing resources to help you get up and running with Blazor in your next project. That's it for this talk, but as promised, I have the QR code for you. So if you downloaded the SSW Rewards app and would like to earn some points and eventually earn some prizes, scan this code now and you will be able to grab some points. Of course, this is on YouTube, so I don't need to wait too long here. Now, if you've got some feedback, I'd really appreciate it. I'll build that into the next version of this talk. Next time I present, hopefully it will be even more amazing than this version. I hope you enjoyed it. Thanks for watching. I'm Jason Taylor.
That was awesome, Jason. Thank you for doing that.
No problem.
You're a very well-prepared speaker. I love watching you. It is obviously sad you're not here in the chapel down here doing this, but how was it doing it from home?
I love working from home. Hey, look, I have my screen down here, just below my main screen. Then I've got my screen up there above my other screen. I've got my lighting, and yeah, no, it's nice. I'm always happy working from home. But it has been 2 years now. I would like to get to a user group. I miss playing pool in the office and eating pizza and having a few beers. So we don't get that here. I have to go and read books after this.
So let's talk about your enterprise projects. How excited are you about .NET 6? And some of the guys, asked Jaco, he said 11 out of 10. Some of the other guys, pretty excited. Oh, actually, even Mehmet was excited, so that's good.
That's amazing.
Where are you on the scale of .NET 6?
Well, I mean, I've been using RC2 and earlier versions before it was available through public channels. So I've actually been subscribing to the updates that are available through the GitHub channel and feeling the pain of trying out this early release software. So I'm very excited about it and excited to get up and running with it quickly so that we can use it in our projects. Especially for the Blazor projects, getting that hot reload experience is really going to be welcome. It's going to help our productivity a lot.
Okay. Are you going to be going the minimal code route?
Oh, you know what? I will think about it a little bit longer. There's a bit of discussion on the minimal code route, and we're actually losing a couple of things with this approach. For example, Steve Smith, our Dallas, called out that we have really nice ways of supplying configuration per environment with the existing options, and that's simply not available with the minimal code route. So I think the community needs to spend some time working with this approach. Obviously, the templates need to be updated because some things are using the minimal code approach, some things are not. So we need to get at least consistent there. And I think wait to hear back from the community, wait to get some experience using it, and then I'll make my decision on that. I certainly love these new using the namespace statements where I don't have that level of nesting. It also makes me think, the convention currently is we have our using statements followed by the namespace. We need to reverse that now. Namespace goes at the top of the file, followed by the using statements. So we see the namespace where we are, followed by the using statements, the things that we need, and then the actual class that we're working on. So that's going to be really cool.
Right, okay. And when you create a new project for a customer on .NET 6, do you need that startup anymore? Or you just
it depends. If we're creating a new project on .NET 6 RC2, yeah, we need the startup because we're not going to do any development without wiring up our nice NSWAG Open API experience.
Right.
And so we're going to need it for that for the time being, at least until NSWAG upgrades to .NET 6. They need to support the minimal templates, and then that's it. I could switch to using something like Swashbuckle, but I prefer NSWAG because it's the only tool chain that provides that complete end-to-end experience in one package.
Right. Okay. All right. Well, I think you've got everybody on the almost everyone on the SSW teams using NSWAG. So you've probably converted a few more tonight. What are the gotchas in converting a .NET 5 project to .NET 6?
I don't think there really are any. I think it's I haven't done a specific upgrade. Oh, actually, no, I have. I've upgraded the Clean Architecture Solution template just on a branch. It's not released yet. I haven't really run into any major gotchas. You know what? Pretty much since, I don't know, .NET Core 2.1 through all the way to 5 and 6, it's been pretty painless, actually. The team always puts together really great release notes, so they'll let you know immediately breaking changes. So just be sure to read the release notes for upgrading to .NET 6. And if there are any breaking changes, check your project to see if they exist. Otherwise, I think you'll just be updating the versions of packages, maybe enabling implicit usings, and maybe enabling nullable by default, which is coming in with the new templates. But yeah, no, I think you'll find it's going to be quite straightforward.
Right. Okay. And even on a very large .NET 5 project, enterprise project?
Do you want me to say it depends? Because I will say it depends. Happy to say it.
I'm just wondering if there's any gotchas. I know we've had some successful migrations, but there's plenty more to go.
Yeah.
But if there are some gotchas, then we need some patterns for migrating.
Yeah. Well, look, I think, I've tackled the main ones with the things that we'll be working with. We have our nice Fluent validation experience. We have a nice OpenAP experience with NSWAG. So I'm pretty confident that that's going to cover it for the time being.
Right.
Obviously I've already upgraded one project to .NET 6, so no, I don't think there's anything major. And just, be sure to check the notes to see for any breaking changes that might impact you.
Okay. When there are in the migration and there's changes to endpoints, do you have any patterns for that problem?
In the migration changes to endpoints? Sorry, what do you mean?
Like if you're doing a migration and you want some changes to the endpoints at the same time?
Oh, okay. I see what you're saying. Yeah, okay. Well, that's not really relevant to an upgrade from .NET 5 to .NET 6. So my advice would be do one first and then do the other. Don't complicate your upgrade by changing the routing at the same time, because then you're going to be trying to upgrade, trying to fix any breaking changes, and also figure out what the hell you did to your routing and fixing up your client and that sort of thing. So yeah, one step at a time. Keep it simple.
Okay, all right. Are you still using T4 templates for things?
No, not at all.
All right, go on. NSWAG Studio, I know it's popular with us, but how popular is it compared with the other ones?
Oh, I don't know. Let's have a look at the NuGet packages. Okay, so fire up NuGet, and what I like is the statistics. We can see Newtonsoft.json is at the top. Is that the latest? Is that what happened to AutoMapper? Oh, there's AutoMapper, so it's there. I like that tool too. Okay, but we're here to see the two main packages, right? NSWAG and Swashbuckle. So let's start with NSWAG. Pop that there. And then we'll grab this one. You get, actually, got it. Okay, so Swashbuckle has 25 million downloads. Well, let's go with this one. 132 million downloads. NSWAG has 15 million downloads. So you'd say based on that, Swashbuckle is way more popular than NSWAG overall. But like I said, I've used both, and I just prefer the end-to-end experience that NSWAG provides. It's one tool that can generate my OpenAPI specification. It can generate a wide range of TypeScript clients and C# clients. And one other thing, it's got the MS build, so I can automate it all. And it also has the tools like Swagger UI and Redoc and API Mundo, all in that one tool chain that you can access to use with your projects. So yeah, I realized that Swashbuckle is much more popular, partly because it's also built into some of the .NET templates now, but I still prefer NSWAG. I think it's the right tool for the job.
All right. And I guess another point is most of the devs on the team aren't into it so much compared to you, because you set it up for them and it's just done once and then it's just part of the build.
That's it. Yeah, so we have conversations from time to time about different approaches, but generally people are happy to stick with NSWAG, especially when they see how nicely it works end to end.
Right. Have you come across Refit?
No, I haven't used Refit.
It allows you to define a strongly typed client for your API, but it doesn't do the generation for you, I guess, if you want more control or something.
Yeah, I heard some talk about that recently at SSW. No, I haven't used it. Okay. To be honest, all of my time goes into, I guess, three things: preparing for presentations, working, or looking after my kids. And that's it. So at the moment, I've had my blinders on, just focused 100% on Blazor. So I haven't had an opportunity to look at anything else.
Right. Okay. Well, maybe you need to free up some time and stop building a to-do app. You could start using Trello or something.
No, I have to improve my to-do app. You might not have noticed this. I'm pretty hard on myself, but I don't have filters to hide the done items. So there's a lot more to be done there. So I'll get it.
Right. Okay. Now, do you like server-side Blazor or client-side Blazor?
I like client-side Blazor. I think, when we first heard about Blazor in 2017, the excitement was not around, well, it was around Blazor, but it was Blazor WebAssembly, right? Running that C# code in the browser. That's what I'm excited about. And really, if I run C# code in the Blazor, that's a way for me to steal CPU and memory from my clients. I can't do that if I run it on the server. That has to be my CPU and memory that they're using. So yeah, Blazor WebAssembly is my preference.
Okay, all right, well, that's good. So tell us about the performance of this. Like, this is kind of, large. It's an assembly. It's, I guess it's a bit larger than Angular, but probably
Much larger.
close to, well, I guess it's close to what Angular 2 was, and we all lived with that for a long time. Angular 2, definitely it's lighter than Angular 1.
Yeah, no, it's much larger, and I think our good friend developer JK said it best when people need to think about Blazor WebAssembly a little bit differently. It's an application that you're loading in the browser, and of course, applications have a little bit of a load time. And so I think when you look at something like, say, this Blazor Train app by Carl Franklin, it has this nice little loading. Well, it's a tiny little text box, but I think we need to build these nice little loading images to show that, hey, this application, it's a serious application, and we want to let you know that it's loading. It's got the loading indicator, and once it starts, it's going to be highly performant. And so, yeah, no, I think we just think about these applications a little bit differently, and just make sure that we give the user a nice experience when that application does load. And of course, there's things that we can do to improve the performance, such as compression and those sorts of things.
So when are you going to fall back to Angular or React for projects?
Wow. I will fall back to Angular, React, or Vue. No, wait a sec. Let's reorder that to Vue, Angular, and then React.
I knew you'd put React at the end.
If it comes up in a client project, and hopefully that client project is, hey, we want to move away from React to Blazor. I'd like to help with that because, yeah, look, I have limited time. And so when I think about the web frameworks that I want to work with, I have great experience with Vue, React, and Angular, but I want to spend most of my time doing Blazor right now because that's what I'm interested in. So I'm probably not going to fall back unless I was joining a development team and they had massive experience with Angular and they wanted to build in Angular. Well, of course, we're going to build it in Angular because that's going to be the most productive approach for that development team.
Yeah,
so for anything else, I'd be recommending Blazor.
I'm definitely feeling that almost every dev that's touched Blazor just wants to keep going because they find it so productive and they go, even if there's, milliseconds in performance difference, customers won't notice it and I'm getting it so much cheaper to them and I'm having a nice experience developing. It's like being in a messy kitchen with pots everywhere and working in a nice kitchen that's clean, big bench space, nice and simple, and you can get a lot more done.
It's kind of interesting because that triggers a thought for me. When we're building in Blazor, we get to write C# in wherever we want, right? In this shared folder. And that's a really interesting concept, especially when you talk about it in terms of clean architecture and being independent of the UI. Well, that shared project is independent of the UI, but then it's also used by the client. So we can put in those types and that logic and those validators and those sorts of things that are going to be used by Blazor, but could just as easily be used elsewhere. So if we wanted to build a mobile app, it can be using those shared projects as well.
Okay.
So we have what I'm saying is we are less dependent on the UI because we don't have to rewrite things like validation and types in the front end, which is something that we have to do with Angular, Vue, and React.
If you had to develop the same large enterprise app in Angular or React versus Blazor, let's just say it's, an Angular React project would take several months of a few devs. what time savings do you think you'd end up with with Blazor?
You want me to say it depends again, don't you?
No,
it depends, Adam. It depends on the skills of the development team. So, if we're talking about a development team that's highly skilled in Angular and highly skilled in Blazor, they're probably going to be faster, I would say, in Blazor, because we get to leverage a lot of that code. We get to use C# and in the front end and in the back end. So there's a great amount of code reuse there. But if the team was highly skilled in Angular and new to Blazor, it's going to be faster for them to build an Angular app. At least at first, we need to think about the capabilities of the team and whether they want to move to Blazor, or whether they have a plan to move to Blazor, and whether there's someone on the team who can kind of guide that effort.
I have seen even good experiences with Node devs and React devs moving to Blazor.
Yeah, that's great. Yeah, it reminds me a lot of when I hear about Java developers who move to C# and never look back.
Yeah, that's right. Brendan Richards, good example.
That's it, yeah.
Callum just sent me a message and said, ask Jason, how hard is it to build a file upload component in Blazor? Because I got the very first version of Blazor, tried to do it, was a lot of work. I haven't looked at Blazor since. Has it improved?
All right, not very hard. We've done it for the recent project, but I would just suggest you check out one of the resources that I presented. So if we go to Blazor train, you can have Carl Franklin teach you how to build an upload component in Blazor. So he'll run you through that very easily. So it's not hard at all. No, it's a very nice experience.
Okay. Oh, well, that was fantastic. Thank you so much, Jason, for tonight. Thank you for all your hard work and giving that to the community. It is awesome. I really enjoyed it. I'm sure everyone else did. And did you use Pomodoros to prepare that talk?
No, I used I had to use a little bit of procrastination and a little bit of a impending deadline.
Right, awesome. Well, that does the job as well.
Yeah.
So thank you very much, and thank you to all the viewers out there. It was a great night, and I look forward to seeing you next month at the .NET user group. Cheers.